So in grade 10, the intro course, you probably you would factor trinomials, and what you notice there is a lot of them had the x squared, right? If you would FOIL it out, you ended up with an x squared term. And those are quadratic functions, right? And the graph is very particular, which is what we call the parabola. So I left the front space there to kind of make our own little intro. So quadratic functions, right? Graph is called a parabola. Okay. And it looks like a horseshoe. Looks like a horseshoe, right? So I just have like a coordinate plane here. So it will either look like this, or it could look like this, pointing up or pointing down. And there's some variation along the way. Yeah. What makes this different compared to linear? We're also going to do linear down the road, but I first start with quadratics. That it has a turn, right? So I'm going to actually point out both of these curves. If you read them, always read your graphs from left to right. So this goes down, 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 down until it reaches a point, a turn, and then it goes back up. So this turn is called, in particular for a parabola, it's called a vertex. Right? And in this case, it's the minimum. We call this the minimum, the lowest point. And it could also be, of course, when the parabola is pointing down or opening downwards, you have your vertex here. And in this particular case, it's a maximum. So this is just giving you a heads up as to what's coming your way. Before I continue, have your teachers talked about Desmos in the past? Have you used Desmos before? It's going to be a great tool to help you out every once in a while if you need to solve some of these. So you can use that to help you. Okay, let's dive right in here. So page 1, a linear function, right? A linear function has the equation y equals ax plus b. And you might be saying, Mr. Dirksen, in grade 10, we had an mx plus b. Does that ring a bell? Mx plus b, m is your slope. Regardless, usually moving forward, we're going to call that's the leading coefficient, which is a. Whatever's in front of the variable is our leading coefficient. So where a is the leading coefficient. Sorry about the lack of space there. Right, leading coefficient, and the constant b, right, the number that's without a variable at the end, is the y-intercept. And next year, or in grade 12, we're going to talk polynomials. So we're going to go cubic functions as well. It produces a straight line since the highest power of x is just 1. Okay, x has an exponent of 1 there. The equation, therefore, has a degree of 1. So the highest power of x determines the degree of the function as well. And you might be thinking, what? Just wait. Okay. Note, y equals ax plus b can also be written as mx plus b, where m is the slope and the constant b is still the y-intercept. So this is the version you saw last year. They're the same thing. If you graph them, they're the same thing. A quadratic function has the equation, watch this, is a quadratic, right? A quadratic function has the equation y equals ax squared plus bx plus c. And the only condition, guys, listen carefully, a cannot be 0. The leading coefficient here cannot be 0, because then it would cease to be a quadratic. Then this whole thing would be gone, right? And then you're down to a linear again. So if you want a quadratic, a cannot be 0. B and C may be 0, right? So these two may be absent when we're looking at some specific example. So a is still the leading coefficient. And I'm not going to lie to you, this year and next year, we're kind of obsessed with the leading coefficient because it tells us a lot, okay? So hone in on that. That's why I'm trying to make a point there. And the constant C, constant means it doesn't have a variable attached to it, right? C is completely without a variable, is still the y-intercept. It produces a parabola. There it is again. Since the highest power of x is, so you're looking at this equation and the highest power is 2, right? We say that the equation has a degree of 2 as well. In fact, all quadratics will always have a degree of 2, right? A quadratic function will always produce a parabola. It points either up or down, and it expands sideways indefinitely. Okay, so it'll either be pointing up or down. It's not a U, guys. It's not a U, which the lines kind of go parallel after a while. It keeps on expanding indefinitely. It opens up sideways indefinitely. State whether the graph of the following functions would be a constant, a linear, quadratic, or not applicable. To be honest, this is just to emphasize. Let's pick out the quadratic functions here. Quadratic. Is this a quadratic? Kind of looks like it, but we say no because we need to see that this is going back up. And so far it's kind of indicating that it's going to continue going down, so it's not a quadratic, right? So quadratic. This is a quadratic. Any other quadratics? This would be linear. This would be constant. You're like, what's the difference between linear and constant, Mr. Dixon? Constant is just when it's y equals a number. There's no variable. It's just like a horizontal, perfect horizontal line. Slope is 0. I don't know if you remember that. Is this a quadratic? It's not a quadratic. I'm tricking you to think it is, but it's not, because we don't have sideways. They never go sideways, okay? So quadratic, quadratic, the other ones would not apply, okay? So just continue with me here. Let's practice determining the degree, type of function, the leading coefficient, remember we're obsessed with this, and the constant, right? The constant has no variable attached, right? That's how you know something is a constant. Students tend to think it's always the last number, and the answer is no. It's not always the last number, because sometimes we try to trick you. We want to test you, right? So here, what's the degree of this function, function or equation? It can be used interchangeably. How do you know the difference? Function, you have something like f of x, right? Then this is in function notation, but don't let that scare you. We treat it the exact same way, okay? So this is an equation because it just has variables. The degree of this would be, you look at x, right? And the degree is just 1. Therefore, the type of function would be considered, we would consider it linear, Where's the leading coefficient at? It's in front of, it's the number that's in front of the highest power, the variable with the highest power. So you go look, well, this is the highest power. So there's a 1 in front. You see that? Invisible 1. So A is just 1. The constant here, you'd have to agree, is the 7. Right? The 7 has nothing attached to it. So that's my... one more. What's the degree of this one? I'll give you candy if you tell me. No, I don't have any candy. I have a snack box, by the way. Did I tell it yesterday? Snack box if you need snacks. What's the degree of this one? Is it 1? Not 1. There's no 2, there's nothing. So it's actually 0. I think you were thinking it, right? But you weren't willing to risk saying it out loud. So that would be constant. Leading coefficient. You would just say NA. There is no leading coefficient because there's no variable. And the constant is 15. Okay. Now, I'm going to stop. I'm going to pause there for a bit, and I want you to fill in the rest, knowing what you know. Okay? And then if you just use pencil, don't use a pen, right? And then I'll take it back in a bit. All right, let's go through it. This one would have a degree of 2 because that's the highest power of x. That means it's a quadratic. So quadratic is the name of that type of function. Parabola is the graph. Okay. Leading coefficient, you go to x squared. In front of it is -3. So it's not -3x squared. It's just -3. Right? It's just that value. The constant is -5. Right? That's your constant right there. Next one, degree is 3. This is actually called a cubic. I didn't expect you to know that. If you guessed it, what did you come up with? I don't know, some creative names. But we're going to do that in grade 12. Okay, cubic. Leading coefficient, you go to x cubed and it's 1, right? And what's the constant in this case? 0, right? There's actually a plus 0 if you'd like, trailing that thing. This one, actually, I'm just going to say NA. You can say NA because here's IPR for you. 1 over x, that's what that is saying. Do you remember that you can write this as x -1 like that? You bring up x and it changes the exponent. So we're just going to say NA here. NA for the whole thing. Constant, we can say 0 because there is no constant other than 0. What about this one? Blast from the past. If you FOIL this out, like let's say this is equal to 6, and then x times x is x squared, x times 3 is 3x, -5 times x is -5x, and then -5 times 3 is -15, sorry. Really? We're going to do this? Not very often. 6x squared plus, this would be minus 2x minus 15. And then you multiply this out, right? 6 times x squared, that's 6x squared. 6 times -2x is -12x. 6 times -15 is -90. So once you have it like that, you can say the degree is 2. Type of function quadratic. If you have two brackets like that with x in either bracket, you're guaranteed it's a quadratic. A leading coefficient, what would that be? It would be 6, right? 6, because 6x squared, and the constant is -90. So you can only answer that once it's all laid out like that. Let's keep going. There are three forms of the quadratic that we study. Okay, and this is the most common, the general. It looks like this. And what does that provide you with? It gives the y-intercept. It tells us without doing anything on our calculator what the y-intercept is. And the y-intercept would be 0, c. Okay? That's the most important part. How do you know it's in general form, guys? No brackets. If you want to put that on top here, no brackets. If you don't see brackets, it's going to be in general form. Then we have descriptive or vertex form. Y is equal to a times x minus h squared plus k. Now I will warn you, right now we're not going to dive too much into these forms. I'm just going to show you what they are. And this gives the vertex, hence the vertex form, right? And this is how you're going to find the vertex just by looking at it. You're going to switch the sign of whatever h is. That's what that negative does. And k is copied down exactly as is. Okay. I'm going to highlight this in a bit, but for now just follow me. Then you have the factored form. That's x minus r times x, come on, x minus s. And so what does it give you? It gives the x-intercepts. And if you forgot all that stuff, I will review that later on when we graph these things. So to find a parabola could have up to 2 x-intercepts. To find the first intercept, you just take whatever number would be in here and change the sign. That's what a negative in front of the variable does. Same with the other, with the s, with the other root or the other x-intercept, we do the same thing. Now, the highlighter here, if you have one, I'm just going to say, hey, this, well, when I know it's in general form, I can come up with a y-intercept and just go, the coordinates of that intercept would be 0, c. Okay, the coordinates of where it crosses the y-axis is going to be 0, c. Then you have the other one, the vertex form. Okay, you essentially take this and put it in there, and the k just follows you as well. So both of these components are used to come up with a vertex. Can I just do something here just to emphasize? I'm going to go x plus h here. Can you go up here and just go plus? That way you see that the sign changed. Okay. Plus there. There we go. And we're going to do the same thing for this one here. Because when you look back at this, you're going to be like, what happened? Why are they the same negative, negative? I want you to see that the sign changes when you take them out. I'm going to use the same highlighters here that I used before. Let's see. I'm going to try something here. See if it sticks. every time you take something out of the brackets, like when you read an equation and you take information out of brackets, like this is your equation, you take this one out, you change the sign of it. So if this had been a +5, it's a -5 when you bring it out, okay? And when you, vice versa, if you were to create the equation, you were to plug it in there, it would change the sign when you plug it into the equation. So there's always a change of signs when you take something out of brackets. K is not in brackets, so it stays. And you're like, don't be too overwhelmed right now because we're going to dive in a bit deeper into them, but I'm giving you a heads up, okay? This is the beauty of it. Regardless of which one you're given, we simply type them into the calculator. That's something some students freeze when the equation is ugly. Just type it into your calculator. It will do the difficult task of graphing for you. And then we'll use second trace to find additional information about the parabola. Okay. Most of the time, you'll be given an equation in general form. We will start the unit focusing on general form and then add the others gradually. These are some of the properties of the resulting graph that can be extracted by simply looking at the equation. So if it's in general form, right, general form, then you can for sure graph all of these things by a combination of looking at it and also using your calculator. So there are some ways to cross-reference and check whether or not you're doing things right. So the direction of opening, right, can be determined by by the sign, by the sign of the leading coefficient. So if A is positive, you know without even typing this in and graphing it that your parabola is going to be pointing up. The ends are going to be pointing up. Guaranteed. Opens up. If you get an equation and you notice that A is negative, you're guaranteed to have a parabola that opens down. Guaranteed. Just by looking at it, not even graphing it. The width of the parabola. So the leading coefficient, right, told us the direction of opening, and the leading coefficient will also tell us the width of the parabola, okay, how wide it is. We simply look at the value of A, not the sign, to determine this part. So a wide parabola is a parabola that obviously is like clearly just opens up slowly, right? It's like a bowl, right? Or it could be pointing down like this. And that's when A, watch this, A is anything between 1 and 0. So any decimal between 0 and 1, not including 0 and 1, anything in that neighborhood will result in a wider parabola. And guys, this is always with respect to a normal parabola. That's when A is equal to 1. And we're just going to try our best to make a normal parabola like this. Okay? That's our like baseline. So it could be wider than that, or it could be narrower. So let's make sure we make a really narrow, it doesn't have to be along the y-axis, it could be right here. Let's make a really narrow parabola. It almost seems like they're running parallel. It will still open up indefinitely, but it's a really narrow parabola. That's very important to understand. And that's when the value of A is bigger than 1. Okay. So I'll give you some examples here. Obviously, A is equal to 1 is this, but then you have two scenarios where it's either wider or narrower. So examples, when A is equal to 1/2, negative 1/2. So both of these are, if you just look at the value, it's 0.5, right? So it's between 0 and 1. You could go 0.7732. You could go A is equal to negative 0.129, right? So just look at the value itself. Forget about the sign. The sign tells us which way it's pointing, but the value itself tells us this is going to be a wider one, okay? 0.99999 is still less than 1. We would still consider that a wider parabola. Over here, A is equal to 1.01, negative 1.01, negative 34.75, positive 34.75, 7 over 5, negative 7 over 5, because this is bigger than 1, right? That's 1.4, right? So the sign doesn't matter, the value tells you the width, guys. Remember that. Sign tells you the opening, the value itself tells us the width, okay? You'll know later on why I'm focusing on this. Right now you might think, can we just type it into our calculator already? You need to be able to challenge some of the answers you're going to be getting. Because if you type it in wrong, you're going to get a different parabola, and this is going to help you determine, wait a minute, something ain't right here. I made a mistake. Right? I'm going to go back and fix it. The y-intercept is on page 4. A quadratic function will always have a y-intercept. There's no doubt about it. It will cross the y-axis at one point. When the equation is in general form, the y-intercept is 0c. That's not a surprise. I told you that already on page 3 at the top there, because it is a point on the y-axis. Note, if the equation or function has brackets on the right-hand side, then it is not in general form. I don't know if you need to, right? If it has brackets, then it's not in general form. So gotta watch out for that. We need to use the calculator to find the y-intercept using second trace 1, x equal to 0, and so forth. So I'll show you exactly how that is done. Grab your calculator. Let's do some graphing here. Okay. And there are going to be hiccups. And if your calculator doesn't cooperate, raise your hand, call me. Don't just suffer there alone. Okay? Sometimes it is a legit issue. Because some of these have been used by grade 12ers, and they enable stuff sometimes that I don't necessarily need for you yet. So that might make yours look different than mine. First thing we're going to do, let's all have the same screen. So what we're going to do is, there's a zoom button here. So we're going to hover, we're going to use y equals, window, zoom, trace, graph. We're going to use all of these. And to start off, we're going to go zoom, press zoom, and go to zoom standard, which is the 6th option. So either press number 6, or you scroll down to 6 and hit enter. Do you have stuff showing up? A graph perhaps, maybe not. It doesn't matter right now. Zoom 6, everybody, right? We press that, that's important. We're gonna go to y equals. Everybody go to y equals, press that button, and we're all gonna go all the way up to where it says plot 1. Let it blink over it, and then you hit enter to deselect that. So it should, if you go hover back down, there should be, none of them should be highlighted, all right? So again, you go to a plot. If plot 2 is highlighted, make sure you deselect it. So, but you go up there, you hit enter. If I hit enter again, now it's highlighted. You don't want that. You want to hit enter, deselect, boom. There it is. Now, this is our x variable right here. See where my finger is next to alpha? That's our x button. That's the variable x. So press it. So y1 is equal to x, and we're going to square it, so press x2. Got it? We're going to graph our first graph. Ready? 11 applied. Here we go. Graph, head graph. You should all see that curve right there. Not too bad, right? It gets trickier than that. But to find the y-intercept, I'm going to change this a little bit. Let's go to y equals. I'm just going to put a twist to it. So go sideways with your arrow until the cursor comes back down. And we're going to go -5. Hit enter. Not -5, -5. Then hit graph again. Oh, what happened to it? It came down 5 notches. I don't know if you can count. It came down 5 notches by doing that. So the y-intercept, I just wanted to show the y-intercept is where it crosses the y-axis. Okay. We know, guys, we know this is in general form because there are no brackets. We know that our y-intercept is -5. But let's say you don't know this. This is how you find it. So hit graph. We're going to go y equals. No, sorry. You know how to, if you hit y equals, to quit any screen and go to your home screen, you press second mode. Second mode is like a quit, which takes you to the home screen. So anywhere you ever find yourself, if you don't like where you are, you can press any of these on top here. You just go second mode, which is quitting really. You're quitting that screen, you go back to your home screen. Okay, that's always going to get you out of it. And if your calculator freezes, you just turn it off, turn it back on. Sometimes when you graph things, it freezes on you. Go figure, right? There's no update for that. So we're going to go second trace. So second trace is will access calculate. And we're going to go value. And this is asking you, hey, give me any x value, and I will give you the y value that goes with it. At the y-intercept, x is equal to 0, right? Right? So go 0, enter 0 there, and hit enter. And you actually now have the coordinate 0, -5. So again, I went second trace value. And then it says, hey, what x value would you like to analyze? Well, I want when x is equal to 0, hit enter. It actually blinks where it's supposed to be. And here you have a coordinate 0, -5. Okay, so that's how you do that. Fill in the following chart. Okay, we're gonna try to do this. We're gonna try to look at all of them. This one, is it in general form, true or false? This one here. No brackets, right? General. Is this general form, true or false? True. No brackets. General. General. Not general, right? What's the other one? One of the other ones. Let's just focus on that right now. General, not general, all right? All of these we can fill in, guys. Opening. So I will ask you this, like, which way is this opening without graphing? Well, A is, look at the value of A. This is A right there. A is negative, so it's opening down. That's my explanation. Next, the width of this thing. Just look at the value of A. A is greater than 1. A is greater than 1. So it's going to be narrow. Y-intercept. What's the y-intercept for this one? I should start having some candies, right? You'd answer if I had candies, right? Maybe. there's a 0 here, so the y-intercept is 0. I like that to be a coordinate. It's 0, C, and C happens to be 0. The constant is 0, so that's how you fill that in. Let's do that up here, plus 0. You can add plus 0 to anything, by the way, because you're not really adding anything. Okay. F of x is just a function, don't be scared. Which way is this pointing? I don't know. Oh yeah, that's my leading coefficient, remember? That's a, because it's in front of x squared. So a is what? Positive or negative? That's all you need to ask yourself. Positive. So it's going to be up. A is greater than 1 still, just looking at the 3.75. Don't worry if it's negative or positive. Just look at the value. So this is going to be a narrow curve. And then the y-intercept is still 0c. How do you know 0c works, Mr. Dirksen? I'm wondering here because I'm kind of... Because this is in general form. The general form, go back to page 3, it says gives the y-intercept. It gives you the y-intercept. So that is your constant. It has no variable attached to it. So this will be 0, negative 2. So let's call this C up here. Okay. What about B, Mr. Dirksen? Isn't there a BX? It could be, but it isn't there in this case. And that's fine, as long as x squared is there. Next, let's play with this a little bit before we do the other ones. I want to make sure we understand what's happening here. Let's go to y equals. Go to y equals and clear that. Like y1, hit clear. Okay. Let's go with our standard quadratic. So we go x squared. Press this button here, x t theta n, right? Square it. And then we're gonna do a second one here. Let's type this one in here. You gotta be careful. When it's a leading coefficient, guys, look carefully, look up here right now. You don't use minus, you use the negative. So you gotta go negative, press negative, 2x squared. Negative 2x squared. Hit graph. Blue, red. Oh. So this one is the x squared. The red one is this one here. Is it pointing down? It is. Is it narrower? If you look carefully, this one is a little narrower than just your x squared. Can you see it? It's hard to see, but it is a little narrower. So it's pointing down, it's narrow. And the y-intercept, is it 0, 0? In this case, just trust me, it is 0, 0. You can tell that it's crossing it right at the origin. Let's do the next one here. This one. Go to y equals. Let's clear that one, the negative 2x squared. We're done with it. Clear it. And let's type this in. 3.75 x squared. Don't forget to square the x, right? And what symbol would you use for that one? Minus or negative? That's when you use negative, right? Anything after the leading coefficient is negative. So complicated, right? So minus 2. And then hit graph. There it is. The red one is the new one, right? So this is what we would consider the normal curve. A is equal to 1. And all of a sudden, he's like, hey, yeah, it's pointing up, check. Is it narrower? For sure it's narrower. You can tell it's narrower than the blue normal curve. Is it negative 2? Is that the y-intercept? Right now, just trust me, right? It's negative 2. It's crossing right there. So it all checks out. So you can use your calculator to help you if you're stuck. I'm fine with that. I want you to try, what are we at time-wise? I want you to try to fill this in, these two here, with what you know. And challenge. This one is a challenge, so I'm going to leave it for now. Okay, if you want to type it into your calculator, go for it. So go for it. Looking at, right? So let me make this a little brighter here. Oh, there. So error syntax. Syntax, if you're into computer science or coding, syntax is like the way you typed it in. It doesn't like the syntax, how you typed it in particular. So you can either quit or you can say go to. Go to quite often tells you what it doesn't like. So if I select the second option, I'm going to hit enter, and it doesn't like just the squared there. So if you go X, this button right here, oh, I'm going to clear that. I want it to come down. So I'm going to go X squared like that. So this is the variable button right here. So I'm going to go here and get rid of that, delete, and go arrow back down. I'm going to insert an X and then square it. Oops. See that ghost box there? You see that? I'm going to hit delete until that is gone. And I'm going to try it again, X squared there. Make sure plot 1 is turned off. I'm going to hit enter there. And let's graph it. So that was the first example, right? Does that make sense now? Okay. So thank you guys. I'm just gonna, if you have a slow graph, follow me. Everybody should just follow me. You'll never have to change this again. So you go second zoom, and you basically want to make sure the last row, the very last row where it says detect asymptotes, you want to make sure that's turned off. If that is on, it takes a lot longer to graph because it's checking for something the whole time. So once you have that off, it'll be much faster. Your graph will just go boom, and it'll be on your screen. Okay. Okay. I'll go over this, and I don't know. I like to clarify because it can happen to you. Watch this, guys. A is positive, right? 3.75, and it's supposed to go up, right? If you, for whatever reason, put in a negative here instead of a subtract, it actually goes 3.75 times -2. So when you graph this, it ends up having a negative leading coefficient, so it's pointing down. So you know, wait a minute, I know better than that. Something went wrong, right? So y equals, that is supposed to be a takeaway right there, not a negative. And then it points it up the right way. Okay, let's fill in the rest here. A is negative. All you care about is A positive or negative. That's all you're looking for. Negative, so it's down. A is bigger than 1. How so, Mr. Dirksen? Because it's negative. Just forget about the sign. Just look at the value itself. So it's narrow. Anybody tried to graph this? Maybe. Some of these might not fit on your graph, so I'll have to show you how to move your window, right? So this would be 0C again. It's in general form. So 0,9 is my y-intercept. I like you to state it as a point, not just, I know in IPR you probably just went like this for your y-intercept. That's an equation. For us, you want to say, hey, y-intercept where it crosses is 0,9 specifically. Okay, so try to stick with that. Next, A here, A is there, right? That is A right there. So A is negative, it's pointing down. A is what? A is stuck between 0 and 1. If you think about it, that's 0.5, right? So it's stuck. So it's actually a wide curve. What's your y-intercept? Curious. What's 18? Nope. It's the constant. In this case, it's not there, so it's 0. It's actually 0, 0 then. When x is equal to 0, y is equal to 0. And the last one, follow me here. Oops, sorry, I'm blocking, right? Y equals, let's clear everything. Just hit clear to go arrow up and down. If you have some kind of weird app open that's called inequalities or something like that, call me. I want to turn that off. You can quit that app. It messes with what we're doing here. So I might have to talk to you individually later. Let's type this in. It's an art to type these things in right. So we're going to go negative 0.91. When I say negative, I mean negative, right? The one in brackets. And then just open the brackets and type in exactly what it says there. X as in variable x plus 2. Close the brackets. Raise that to the power of 2. So hit the x2 button. And now it's not negative. Now it's minus 3. And before I graph it, what do we already know? It's not general, right? I'll write that up here. Not general. However, did you notice if you go to page 3 that all of them have an A? They all have A right in front of the thing. Like, I'll just show you real quick. The leading coefficient is in front of the x squared here. It's in front of the brackets, and it's in front of the brackets here. So A is actually accessible to you regardless of what mode, form you're in. This is A right there. So still, A is negative. It will be pointing down. A is stuck between 0 and 1. So this will be a wider, we would consider this a wider or wide parabola. And can we say the y-intercept is 0, negative 3? Can we say that? No, because it's not in general form. Unfortunately, we cannot. So here's my lesson right now. You type this in, hit graph. I hope this works for all of you. I hope it. So graph. You see it? I hope you all see it. Okay. So we have enough information to figure out the y-intercept. How do we find the y-intercept again? Oh, Mr. Dirksen, I'm just going to count. No, don't do that. It's just approximately. We want to know exactly. So here it is, guys. Second trace enables you to see these functions. We're only going to use 1 to 5. 6 and 7, never. In this course, you'll never use it. You won't use it in grade 12. This is for like calculus, higher level courses, right? University. 1 to 5. So value, and then what is x equal to at the y-intercept? We know it's x is equal to 0, right? That is for sure. So we're going to hit 0, enter 0, I mean, then hit enter, and there it is. You see it? It's negative 6.64. It's negative 6.64. And I want you to have that rounded to 2 decimals. Don't be scared to do that. Yeah. Yeah, what do you get? Negative 3.76. Can I see your calculator? Can I show it the whole class? Okay. Thank you for bringing it up. So, right? Curve looks different. I agree. So let's see what happened here. Am I wrong? It's come up pretty wrong, right? Let's see. Y equals. Oh, do you see it? Look at the paper, and then look at your. See this? It's 9.1. It's supposed to be 9.1 up here, and you have 1.9. See it? Okay. Honest mistake, right? That one would have been hard to catch, to be honest, like as a student, because everything else will check out. It's wider, it's pointing down. We're doing good. So let's try it again. Now it looks exactly like mine, follow the same steps. And don't be scared to ask, because everybody's learning from that. Okay. Okay. Any other questions? Clear? You like your calculators? I hope so. This is what I'm going to say, guys. If in doubt, use your calculators. However, some questions are designed to only take 5 seconds. If you enter it and you find your graph and do all of that, it might take you a lot longer. It's designed to just do a quick boom, this is the answer. Like where is it opening? If you have to type that in and find out, it's gonna eat time away. So I kind of need you to have that general knowledge to do this. So I'm gonna assign this as your homework, this bottom here, for now. I want you to fill that in. If you need to use Desmos, use Desmos. It's fine with me. Right now, I would like you to also use your calculator though. One more thing here, guys. One more thing. I still want to talk a little bit more. Sorry, information overload, I told you. Let's say you want to see more to the bottom of this thing. You want to like see more down here. That's where your window comes in. Press the window button real quick. And look up on the screen right now. I want you to focus on only 4 entries. There's something called Xmin, Xmax. That would be, Xmin would be limit here, and the Xmax is the limit you can see here. And then there's Ymin, Ymax. The Y minimum is like your bottom, like the bottom of the screen, and the Ymax is the top of the screen. So if you want to see more to the bottom of this thing, what would you change? Ymin. Let's double that. Let's go -20. Oh, minus or negative, Mr. Dirksen? I don't know. I'm writing a test. I can't ask. So I'm going to go -20 and see what happens. I'm going to hit graph. Come on, it's supposed to complain. Did I crash it? Oh, it didn't. Okay, I'm going to try it again. -20. I forgot to hit enter. Enter. Oh, syntax. It doesn't like that. So I'm going to say go to the error, go to the mistake, hit enter. And what do you know? It tells you I don't like that minus. So it has to be a -20 for that to work. Hit enter. Then hit graph again. Now you see the bottom here is -20. If you put in -200, it will show you like -200 towards the bottom of the quadrant, right? So bottom half of the coordinate plane. So you can actually adjust these as you see fit, as you need. So for example, follow me. Go to y equals. I'm going to do an experiment with you here. Let's type in, let's go to the back of this equation that's already in there. And let's type in 30. Let's have just 30 in the back there. And let's hit graph. Uh-oh, where is it? The answer is it's down here. That's just an example. I'll talk more about that. So we're going to go window. I'm going to change that to -50. Just an arbitrary. I'm just going to go make more of the bottom be seen by my window. Hit graph. Oh, enter first, sorry. Then hit graph. There it is. So we found it, right? So we can move our window according to our needs. Remember what I told you to press at the very beginning? I told everybody to go zoom and then standard, right? What that does is it resets your window to a 10-10-10 window, like everything is 10. So if you ever mess up, it might happen. And you're like, oh my goodness, like I can't see nothing now, like I'm so lost. Zoom 6 gets you back to a standard, and then you change again as you need, right? So if you completely lost zoom standard, kind of saves you there. You can also try zoom fit. You know, if you're throwing a fit, you know, try zoom fit. I'm just saying. Zoom fit tries to find the graph as best as possible. It doesn't always work. I wouldn't rely on it, but let's try it right now, for example. Ooh, it's not bad. Right? It's not bad at all. So try to find it and so forth. So there's going to be a lot of little tips and tricks that I'm going to show you. Everything else, I think we're going to leave that for tomorrow. How about you take some time right now? It's going to be, the homework is almost nothing, right? I just want you to fill this in either by using your calculator or just reading it as it is and filling in those pieces of information. Try to find the y-intercept using your calculator if you have to, right? If it's not in general, you have to. Thank you, guys.